A very good evening.
Hi, good evening. But I can't see you now, but I think it's okay.
Okay, you can't see me?
No.
Oh, okay. So, but the audience and I can see you. Will that work with you?
Yeah, no problem.
Okay. Sir, so a very good evening and welcome to the 50th episode of the Dr. Battisi show. And please brief us with your introduction on your startup and who you actually are, a little bit of your background.
Uh, okay, so yeah, thank you for this invite and thank you for inviting me to your show. So I am Dr. Debayan Dasgupta. I did my PhD from Indian Institute of Science, Bangalore. I completed my PhD in 2021. Yeah, 2021. Uh, by My background is in electronics engineering. So I completed my electronics engineering BTech in 2013. It's a long time back. Then
Yeah.
I was working in as a government officer in the West Bengal State Electricity Department. So I was an assistant engineer there, and then I quit my job and I joined the Indian Institute of Science, the Center for Nanoscience, um, as a master's student. And then I converted my master's program to a PhD because I liked the research program that was there. Uh, so my work, my entire research work was based on something called nanorobots. So nanorobots, for the people who do not know, the idea stems from uh, the idea comes from 1970s. Actually, the idea of nanorobots came when the idea of nanotechnology was introduced by a person called Richard Feynman. He is a physicist at Caltech. He was one of the people involved in the Manhattan Project, the atom bomb project. Uh, so, in one of his talks, he says that nanotechnology gives you the ability to store tremendous amount of information in a very small space. And to explain that, he said that all of human knowledge can be fitted on the pin of a head, on the head of a pin. So this was his introduction to nanotechnology, and of course, in 1970s, he was also giving ideas about quantum computers, about using quantum systems to store information and all of this. But also in that same talk, the name of the talk is, I think, there is lot of room at the bottom. This was the title of the talk. So he says that imagine if your surgeon, if the surgeon can be roaming around in your body, and if it can find disease sites. So you take a surgeon, you take the person who is doing the surgery, you shrink that person to a size of a cell or maybe a slightly bigger than a cell, and you put that person inside the human body, and then that person can flow through your blood veins, through your vessels, looking for disease sites, looking for bacteria. And when they find this problem, they do the normal surgery. So they take out their tiny knife and they take out their tiny uh, instruments and cut out this problem, so that this person is always there inside your body trying to cure you of all diseases. Of course, his implication was for cancer, for bacterial infection, and at that time in 1970, this was thought to be a science fiction. Even today, it's very close to science fiction. But I joined Professor Ambarish Ghosh's lab. So Ambarish Ghosh is a faculty at the Indian Institute of Science. He is a Santi Swarup Bhatnagar awardee, and he did his PhD in Brown University, and he did his postdoc in Harvard. So while at Harvard University, he, along with his advisor, developed something called magnetic nanorobots. So magnetic nanorobots are very tiny structures. These are helical structures. So they are made of glass, and they are helix. So their length would be about 3 microns. It can be smaller. The length is about 3 microns, and the width, so these are very cylindrical helices. The width is about 300 nanometers. So to give you an idea of this size range, take human hair. So the diameter of human hair is 100 microns. So these nanorobots are about 100 times smaller than the diameter of human hair. So the area of the human hair,
God.
you can place, yeah, so if you put it here, it's about 100 times smaller than the human hair. And they have a little bit of magnetic layer on them. So you can control them by a magnetic field. So basically, so imagine a corkscrew, which is very small with a little bit of magnetic element on them, which has a magnetic moment, and then you subject it to a rotating magnetic field. So it's following this rotating, so the magnetic vector is going like this, and it's following this magnetic field. So it's moving, it's doing a corkscrew motion, and thereby it's going forward. So this was the instrument with which Professor Ambarish's lab was already working on when I joined the lab. And my first project was to see if we could use this nanorobots to measure viscosity. So this field of study is called rheology. It's called microrheology. So my first job was to see if we could see in any way if this nanorobots could be used to measure the viscosity. And why this would be possible is because when the nanorobot is moving through a fluid, it's basically encountering friction from the fluid, and that shows up in its dynamics. So there's a lot of physics behind it, but it's possible. And that was my first research project, which came out as a paper, and then we showed that you could use nanorobots to do very local rheology, so to do very local measurements of viscosity. This, of course, has a lot of will have a lot of applications in biology. But my next project, which was a kind of follow up on this, and also what our seniors was doing, and I will talk about that in a while. That is very interesting what he was doing. So the follow up of that was trying to do this, trying to take this nanorobots and try to probe cancer. And so what we found was that cancer, the general tendency of cancer is to eat up their surrounding tissue, secrete their own extracellular matrix, and then move. So that is the way cancer metastasizes. So when I was trying to probe these cancer cells, what we found was that the extracellular matrix that's secreted by cancer is sticky in some sense. It's more sticky than natural collagen. And
Right.
the reason why this, and the reason why this happens is because cancer is known to be hypersialylated. So sialic acid is a very charged molecule. So whatever the cancer secretes also has a lot of sialic acid, and that's how the nanorobots get stuck to the cancer secreted matrix. So this was the second paper, and of course now there are other lab colleagues and juniors who are taking this project forward and trying to detect cancer cells in peritoneal cavity. So now going back to my lab seniors work, because that is how this entrepreneurship and all of my other things started. So that was in some sense the start. So my senior, when I joined, his name is Malay, and his project was to try to put nanorobots inside a live cell. And he did manage to do that. He managed to put nanorobots inside a living cell and then move them here and there. So basically, he could draw patterns inside living cells, and that was published in a very good journal, and then it created a lot of news, a lot of buzz. And Dr. Shanmukh Srinivas, who is a dentist, who was I think at that time he was a dentist in Apollo, he read these news articles, and he contacted Ambarish. He said that, is there any way these nanorobots can be used in to improve oral science? And he had a few ideas, and one of those ideas was, because of the size range of this technology, of this nanorobots, what he was saying is that it would be very easy for these guys to move inside dentinal tubules. So dentinal tubules, the size range is, I guess everyone knows, is the size range is about 300 to 500 nanometers up to 1 micron, and the length is very long, so it's about 2 millimeters long. And that's exactly the reason why current drugs cannot penetrate deep inside, and therefore the bacteria the E. faecalis bacteria that remains inside cannot be treated. So our idea was to drive nanorobots deep inside the dentinal tubules. And remember, I said that they have this iron coating on top.
Yeah.
So now, because of this iron coating, you can basically do what you do with induction cookers. So you can remotely use magnetic field to heat up these structures and kill bacteria locally. So this was a very new kind of way of killing bacteria. Of course, we are using it in a lot of other applications right now. So this was the start of the project and the company, which is called Theranautilus. And so we are the first nanorobotics company in the world. There is of course
Oh
another
God.
company in California, which is called I
Is
think
it
Bionot Labs.
Neosis?
No, no.
Okay, okay, that would be nano. Neosis is robots, just robots.
Yeah, so I know about Neosis. Yeah, I know about them. But Bionot Labs. So incidentally, Bionot Labs have had also licensed one of the patents of Professor Ambarish. So in some sense, their technology is also kind of very similar to what we do. But yeah, we are the first nanorobotics company in the world, and we are using nanorobots. Right now, we are using it for oral health, but of course, the hope is at some point it will go and target cancers, hopefully the ones which doctors deem inoperable right now.
Correct. Sir, firstly, I would like to thank you. And secondly, I would like to share that this has been the most incredible intro that I have ever interacted with, because in all the 50 sessions, and if somebody, discussed with me in such a depth and I knew a PhD mein aisa hota hai, I would have chosen such a career for myself, for sure.
Oh yes, yeah. PhD. I fell into PhD in some sense. It was not something that. Well, I wanted to be a scientist when I was a small kid, but I did not know the path to it. But yeah, I think
Correct.
some way it led me to here. Yeah.
Right. Sir, so which year the startup was founded?
So this was founded in, I think the official date is October 2020. But
Okay,
when we founded the startup, work has already been going on for over a year at that point. So
correct.
the actual work started in 2019.
Right. Sir, it's in private limited.
Yes.
And like, how much team we have right now?
So right now we have a team of 5 or 6, I think. Yeah. I mean, we have some
Okay,
interns, so
right.
6. Yeah.
Okay, great. And sir, it's such an honor to be in conversation with a company which is an Indian and which is one of the first in India who has entered this industry. So, to me, being a dental surgeon and an Indian dentist, I am so proud right now.
Thank you.
Yeah.
Yeah, but
Sir,
we are not just the first in India. We are actually the first in the world.
right,
We hold
right,
a lot of the patents that drive this technology.
correct. Sir, so firstly, how can a dentist can work with you? Is that a possibility?
So right now we already have a dentist as a founder in our team.
Right,
So most of the brainstorming and most of the ideas that is there available that is needed for oral health is already available with us. And I mean, the dentist, I mean, Dr. Shanmugh, he's a very good scientist and he's doing.
right,
But we do have, I mean, not right now, but in near future we will have the need for a lot of clinical data, and this is for some of our algorithms that we are developing. So a lot
correct.
of it is still in very preliminary research stage. So at that point, we would be needing collaborations with hospitals. Where we can get patient data, but none of it is really official, or none of it is very clear as to what sort of data or what sort of help we would need right now. So yeah, I mean, anything from a medical background, I think we are very well sorted. Having said that, we do have a very dire need for more engineers who are very capable, because we are,
Right.
at the end of the day, we are a we are a hardware deep tech company. So to build the hardware, we need engineers. Yes.
Correct. Sir, so some people may get confused the difference between robotics and nanorobotics. So can you please explain to them?
Okay, so when you say robotics, what pops into your mind is something like, let's say, those four-legged creatures, or those two-legged humanoids that you make, that are made by a lot of these companies. So that is macro robotics, and that is already used by a lot of industries right now for automation. Uh, Drones and
Right.
underwater drones can also be considered as some sort of robotics, because they do use the same control systems. But when you come to nanorobotics, the difference is, we call it robotics because at the end of the day we can control and design its path. So we can guide it, and we can tell it where to go, how to move, where to do. So in
Right.
that sense we call it robotics. But also in terms of degree of freedom, so where it can go, how far it can go, so that's why we call it robotics. But in some sense this is much more closer to how bacteria behaves in a fluid, and that is why it's helical in shape. So if you study the physics of it, if you try to figure out how these things should move, you will see that you need at least some sort of shape asymmetry. So bacteria moves
Correct.
because they can flap their tails, or sperms move because they can flap their tails, and that sort of asymmetry is needed to move forward. So what we are doing is we are sort of trying to mimic those kind of motions, and that is why this shape is very important in this sort of motion, or in this sort of nanorobotics. Other than that, nanorobotics is of course a very vast field. So there was, of course, I think a Nobel Prize in nanorobotics a long time back, like 2013 or 16, I guess. But those guys, what they were doing is, it's much smaller. So they were doing it at a molecular level. So they could make molecules that behave in a certain way based on the bond stress and bond angle and all of that. Ours is a much bigger in compared to theirs, because they're of course molecules. We have about a micron or up to 500 nanometers of things. And then there are also other groups in the world who make something of millimeter scale, and that can also be termed as micro or nanorobotics. So it's a vast field with different length scales going about, and all those length scales have their own specific problems. So when you say that when someone says that I want to use nanorobotics to solve this problem, uh, we need to look at that problem very carefully, because there's a lot of things that are not very obvious. So if you say let's say I want to puncture a cell, or I want to target something, it's just not possible, because the amount of force that this nanorobots can generate is not enough to puncture a cell. So those sort of problems
Right.
always keep coming.
Okay. Sir, so when can we see the very first product in dentistry using nanorobotics?
So, okay, that's a very interesting question. So, our company started with trying to solve endodontic reinfection. So, we published a paper. We saw we showed the proof of concept and all of this, but then we shifted to trying to solve dental hypersensitivity. So, what we realized is, if you can move from the root canal, from the central canal to outside through the dentinal tubules, you can also move from outside to inside. And then if you do your chemistry right, you can basically block the dentinal tubules.
Oh, wow.
And that is the way to solve dental hypersensitivity. So currently what Colgate or Sensodyne or all of these people, what they try to do is, when you brush with dental hypersensitive toothpaste, you basically form a smear layer. You basically form a layer on the exposed dentine. And
Correct.
that layer goes away in a day or two, and the pain keeps coming back. So dental hypersensitivity is a chronic problem. But with nanorobots, you can actually push them deep inside. So the problem is always the depth, right? So if they are very
Yeah.
deep inside, then regular brushing will not distract or not get these blocks or these nanorobots eroded, and the blockage remains permanently. So there's a permanent solution to dental hypersensitivity. So we have done this test, we have done the animal trials for this idea, we have patented it, and we saw that I mean, the animal results are amazing. So the pain goes away,
wow.
and the animal recovers like anything. So we have started writing the paper, and we are going to publish it. But we have also sent this nanorobots for ISO certification. So that will take 6 months to 1 year, and after that we'll be in a position where we can start human trials. So in a couple of years, so by the end of next year, we are hoping that we can hit the market. But if not next year, definitely 2025, we should be hitting the market.
Perfect, sir. So it will be like over the counter product, or it will be through the dentist? I mean, through the doctor.
So right now it would be through the doctor. The reason why we are, of course, we are not businessmen, but this is what we envision it will happen, is because it needs a little bit of acceptance from the dental community or from the doctors
Right.
community in general. And
Exactly.
to do that, it has to be through the dental clinics. So that's how we envision it.
Okay, perfect. Sir, so how do you, now that you have such a deep depth of dentistry in India, so overall dentistry in India and generally dentistry in the next 10-15 years, where do you think it's going?
Okay, this is a very tough question for me. I'm not a dentist. uh,
Yeah.
but yeah, actually, Shanu could be much more better equipped to answer this. But I think we are, as a company, we are about to change the way dentists do dentistry. I don't know how much of an impact this will have on. Of course, it will have an impact on the patients as the end user, but in terms of thinking, I don't know if it will change patient behavior that much, but it will definitely change the way dentists think about their science and their practice. The reason being, suddenly now you have all these tools which allow you to do microsurgery on dentinal tubules, and a lot of problems, as I understand, I mean, from my limited knowledge in dentistry, as I understand, a lot of problems happen due to the inaccessibility of dentinal tubules. Um Also due to inaccessibility of various parts around in and around the teeth. So I feel like this is going to change the way people think in terms of treating problems in dentistry, and I think that's a very good thing, because and we actually, I mean, I think we would be developing the skill set to solve all of these problems one by one.
Right. And I guess, sir, I read it on your site when I studied the site that you guys are incubated as well by an organization. Is that correct?
Yes, so we are incubated inside the Indian Institute of Science. So IISc has a in-house incubation facility. So,
Right.
so that's where we're incubated. Yeah.
Okay, sir, so right now, like, there is no way that you have, applied for the funds or talked to the investors. It's like you have guys, your own money is into it.
So we have raised equity money, and
Okay.
this was led by IIT Roorkee. So IIT Roorkee also
Oh,
has
wow.
um, a startup incubator, just like IISc. So
Right.
IISc also gave us seed money. They also gave us a lot of CSR fundings, which allowed us to do our initial research. And
Wow.
then when after we exhausted that money, we really needed funds to start the animal trials and all of this, which is when IIT
Correct.
Roorkee led around and allowed us to raise some money. After that, we actually won the BIRAC BIG grant, which is a Government of India grant. And that is what's allowing us to go through the ISO certification process.
Oh, wow. Okay. Sir, so very common question. usually students ask that, if they want to publish a research paper, now that you have already done in such a good journals and you are already a PhD scholar yourself, so what you would give to them, that if somebody wants to publish their first paper, and if they're not a dentist yet, they are just in the process of being a dentist, so what can they opt for? How, like, the journals you can suggest them or the guidance you can give them?
So I don't think I am qualified to guide doctors to publish journals because from what I understand, their way of doing research, the methodologies are very different from the way we do research as
Correct.
physicists and engineers. So, but
Yeah.
I read a lot of medical journals, and I see a lot of them is reviews or uh, more of an, how do I put it? So
Perspective
more of,
of one dentist over.
yes, yes.
Yeah.
So it's more of an empirical study.
Right.
So so that is good. I mean, that gives us a lot of data about what's happening in a population. So these studies are done at a population level, and they give us a broad overview about what are the diseases or what are the problems specific to a particular population. But having done that, I think that's where most of Indian research stops, and that is not really good, because once you have figured out that there is something different in this population, it's always good to go down and try to figure out why is this happening. So is there a lifestyle difference? Is there a genetic difference? What is that difference that's showing up in this population as compared to your other population or some control population that you're comparing it with? So this is one thing that I think would help researchers like us understand certain problems here and there. But in general, for a undergraduate, I think writing reviews is a very good exercise because that gives them a much broader knowledge about the state of the art. So that's also something that they can look for.
Correct. Thank you so much, sir. We are so much grateful, and especially I am, because on such a short notice, you said yes for this live, and grateful.
Thank you so much for inviting me in your call. Yeah.
No problem, sir. And I'm going to ping you later. And I hope you see this live with the right faces and the right conversation on the link when I share it with you later.
Sure, sure. Thank you.
Thank you so much, sir. Have a very good evening. Thank you.
Thank you. Bye.
Bye.